Hi all, my name is Ravi Prakash and welcome to the 7th class of Permutations and Combinations. Right, 7th class, very important. We're discussing a series of very important questions here, covering all the concepts, right? So every question and every concept we'll discuss, which is possible, you'll get in mocks or in any exam, right? Okay. And this is 16th question here. Number of diagonals in a convex polygon is equal to 65. Okay. Find the maximum number of intersection points of diagonals. This is the question. Fine. Okay. See, first answer, if you observe this question carefully and if you watched the last video, we are discussing about the intersection point of the diagonals or intersection point of the lines and circles or triangles, right? So you can sense that, okay, there's a number of diagonals in a convex polygon is equal to 65, and since all the diagonals are equal, sorry, all the diagonals are straight line, right? So when all the diagonals are straight lines, so intersection point of 65 straight lines is nothing but 65C2 into 1. So answer should be 65C2 into 1, right? But it is wrong. But it is wrong, right? Now why it is wrong? It is wrong because it is not necessary that inside the diagonal, okay, inside the polygon, every diagonal will intersect once. That's not necessary, right? See a hexagon here. For example, see a hexagon here. This is a diagonal. This is a diagonal. They need not intersect, right? They need not intersect. This is a diagonal. And this is also diagonal. They need not intersect. So each diagonal will not necessarily intersect inside the polygon, right? So this is wrong. Okay, so how to do it now? So basically that means number of intersection point of diagonals again we have to go to basics now. Okay, so how do we, I told you, right, how in last video how to find number of intersection point of diagonals. So finding number of intersection point of diagonals, go back to the minimum case, and then maximize it. Okay, so what is the minimum case here? So minimum case here is diagonals intersection point will occur in which figure? At a minimum. So diagonals intersection point will occur in minimum a quadrilateral. That means a figure having 4 sides, a quadrilateral. So diagonals intersection points will occur at a minimum in quadrilateral. In triangles it won't occur, right? In triangle there is no diagonal. Okay, so it won't occur. That means it starts from quadrilateral. That basically means what? If it starts from quadrilateral, then this intersection points of diagonals is dependent on the number of sides of the figure, right? Number of sides of the figure. Okay, so it depends on the number of sides of the figure, right? So how to find if number of diagonals in a convex polygon is 65? What is the number of sides? How do we know it? We have discussed this point in the geometry also, right? Number of diagonals in any convex polygon is given by n into n minus 3 divided by 2. But I told you at that time that I'll prove this point in geometry, in permutation and combination. I'll prove this point, so I'll prove it, right? See how to prove this point now. See, in any suppose there are like 4 points here. There are 4 points in any figure. So taking these 4 points, how many straight lines we can draw? We can draw 4 C2 straight lines, because lines will be drawn from selecting any 2 points. Okay, so any 2 points we select, we can draw a straight line, right? So we can count here, right? 1 2 3 4 5 6. I can draw 6 lines here, including 2 diagonals. But what is the value of 4 C2? 6 only. But how many diagonals? Only 2 diagonals, right? So number of diagonals is what? 4C2 minus 4. What is 4? 4 is the number of sides. 4 is the number of sides or number of points, you can say. There are 4 points, so there will be 4 sides. So just total number of points total number of lines minus number of sides will give you the number of diagonals, right? So total number of lines minus number of sides will give you the number of diagonals, that is 4C2 minus 4. Okay, so if there is an if there is n point, So if there's a n point in a polygon, so I can draw n C2 straight lines and subtracting number of sides. So n points, so n side, right? So n C2 minus n. When you solve n C2 minus n into n minus 1 by 2 minus n, you'll get the value as n into n minus 3 by 2. Okay. So number of diagonals in any polygon is given by n into n minus 3 by 2. Using n points, you can draw NC2 straight lines, because selecting any two straight lines will give you one. Sorry, selecting any 2 points will give you one straight line, right? So if there are 4 points in a plane, you can draw 4 C2 straight line. If there are n points in a plane, you can draw n C2 straight line. Okay, there is a funda. So number of diagonals in any n-sided polygon is what? In a convex polygon is what? It is n into n minus 3 by 2. N into n minus 3 by 2. Okay, nice. So that means I can write this as n into n minus 3 by 2 is equal to 65. N into n minus 3 by 2 is equal to 65. Therefore, n into n minus 3 is equal to 130. Now, you don't always need to solve a quadratic equation. You can simply put by logic, right? N into n minus 3 is what? It is 130. So, you can see here, product of two terms is 130 with difference of 3. So, obviously, what is satisfied? 13 and 10. 13 and 10, right? Obviously. Therefore, n is equal to 13. That means it is a 13 point. It is a 13 point polygon. It is 13, like this, a 13 point polygon. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's a 13 sided polygon, 13 points, right? Polygon. Okay. So it is a 13 point polygon. We don't need to draw it, right? Just for this sake of understanding, I've drawn this 13 point, right? So will give you this, will give a 13 sided polygon. This will give you a 13 sided polygon, like this. Okay. So in this 13 sided polygon, there are how many diagonals? There are 65 diagonals, right? We know it. Now, what is the maximum number of intersection points of the diagonals? So I know that the minimum case for diagonals is a quadrilateral. In a quadrilateral, every two diagonal will intersect at one point. So always go to minimum case and then maximize it for intersection point, right? In circles, what we did? We need minimum 2 circles. We maximized it. 2 circles will intersect at maximum 2 points. In straight lines, what we did? 2 straight lines and we maximized it. That means 2 straight lines at maximum will meet at 1 point. Similarly, intersection point of diagonals will occur at a minimum in quadrilateral. Okay, and in quadrilateral they'll intersect at any 1 point, right? So every 4 points, that means every 4 sides or every 4 points will form one quadrilateral, and one quadrilateral will form one diagonal intersection point, right? One quadrilateral will form one intersection point of two diagonals. Okay, so again listen this point. Every 4 points will form one quadrilateral, and every 2 diagonal of quadrilateral will form one intersection points. But in quadrilateral, only 2 diagonals are there. So one quadrilateral will have how many intersection point? Only one intersection point, right? So number of intersection points of diagonals is equal to, you can write here, number of intersection point of diagonals is equal to number of quadrilaterals is equal to number of quadrilateral, right? How many quadrilateral we can form here? There are 13 points. So quadrilateral can be formed by selecting any 4 point, right? 13 points are there. How many quadrilateral you can select? 13C4. Every 4 point will give me one quadrilateral. So 13C4 quadrilaterals we can form, and in every one quadrilateral there will be one intersection point of diagonals. What is the answer? 13C4 into 1 is the answer for this question. To solve it, what is 13C4? 13, 12, 11, 10 divided by 24. It is 715. It is 715. So 715 is the answer for this question, right? Very nice question. Very good question, right? Again, let me repeat it. Number of diagonals in a convex polygon is 65. Number of diagonals, we have proved it, right? In this video only. Okay, that number of diagonals is how much? NC2 minus n, which is what? N into n minus 3 by 2. So n into n minus 3 by 2 is equal to 65. So from here we got n is equal to 13. We got n is equal to 13. That means it's a 13-point polygon, 13-sided polygon, right? Now, number of intersection points of diagonals. It will always found by, right? So what is the general rule for intersection points? Get the minimum case and then maximize it. So what is the minimum case? So obviously two diagonals will intersect at one point. That is the minimum case of diagonals intersection, right? Two diagonals will intersect at one point. So two diagonals where in which figure we'll get two diagonals? In a quadrilateral. So every quadrilateral will have two diagonals and two diagonals will intersect at one point. Since there are 13 points here, how many quadrilateral we can form? So like this, we can form selecting any 4 points, selecting any 4 points. This is a quadrilateral. And this will have one intersection point of diagonals. Right, this is also quadrilateral. It will have one intersection point of diagonals. Right. So like this, how many quadrilateral you can form? I can form 13C4 quadrilateral. How a quadrilateral will be formed? By selecting any 4 points. Okay. How a straight line is formed? Selecting any 2 points. So NC2. If there are n points, there are NC2 lines. So how many quadrilateral will be formed? If there are 13 points, 13C4. Selecting any 4 points will give me a quadrilateral. 13C4 different quadrilaterals we can make, and each quadrilateral will give you one intersection point of diagonals. That is 13C4 into 1. What is the answer? 715 is the answer for this question, right? Very good question. Okay, I hope it is clear. I hope it is clear, this part. Question 17 now. Question 17. Find the number of straight lines, triangles and quadrilaterals if there are 10 non-collinear points. Right, I should write quadrilateral that can be formed. Right, find the number of straight lines, triangles and quadrilaterals that can be formed. This is like a lower arrow, that can be formed if there are 10 collinear points. Okay, so first 10 non-collinear points, right? So 10 non-collinear points. So you can solve it. See, there are 10 non-collinear points here. So 1, 2, 3 at random, there are 10 non-collinear points. It's quite easy in this case now. Okay, so there are 10 non-collinear points, quite easy in this case now. Simple. How many straight lines I can draw? I can draw 10 C2 straight lines, because selecting every 2 point will give me one straight line. So I can draw 10 C2 straight line. Again, back of the mind meaning of 10 C2, right? If I numbered all these points as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So what is 10 C2? 10 C2 means I can form groups of 10 C2 means I can form 10 C2 groups of 2 things. 1, 2, 1, 3, 1, 4, 1, 5, 2, 5, 2, 6. Like this I can form 10 C2 groups. So what is 1, 2? 1, 2 will give one line. What is 1, 3? 1, 3 will give one line. What is 1, 4? 1, 4 will give one line. What is 1, 5? 1, 5 will give one line. What is 2, 5? 2, 5 will give one line, right? So like this, how many lines I can form? I can form lines as per pairs. Alright, as per selecting any 2 points. How many groups of 2 lines, 2 things I can form? I can form 10 C2 groups of 2 things, and every group of 2 will give me one line, right? So 10 C2 lines. So selecting any 2 points is mean 10 C2 lines. So number of straight lines is how much? 10 C2. Okay. Number of triangles. 10 C2 is the answer for number of straight lines. Okay. That is 45. You can solve it. It is 45. For triangles you need to select any 3 points. Okay. That is 10 C3. Out of 10 non-collinear points, if you select 3 points, okay, that means you can form 10 C3 triangles. You can form 10 C3 triangles. Okay. How many quadrilaterals you can form? If there are 10 points, selecting any 4 points, how many quadrilaterals you can form? 10 C4 quadrilaterals. Right. What is 10 C4? 210. What is 10 C3? 120. What is 10 C2? 45. So you can form 45 straight lines, 120 triangles and 210 quadrilaterals if there are not 10 non-collinear points in a plane, right? This is the funda behind it. Okay. Now, move to question 18. Question 18. Right. Find number of straight lines. Now another variety, straight lines. Find number of straight lines, number of triangles, and number of quadrilaterals. Number of quadrilaterals if there are 11 points in which 5 are collinear. If there are 11 points in a plane in which 5 are collinear. Okay, this is a good question now. Collinear, right? See, collinear. First we'll do for straight lines. Now see straight lines here. See, there are 5 points are collinear, right? Let me draw it. For the first, let me draw it, right? You don't need to draw it always, but since it is starting, okay. 1, 2, 3, 4, 5. There are 5 points which are collinear, single line, and other 6 they are non-collinear. 1, 2, 3, 4, 5, 6. Let's say like this. So there are 11 points in this plane like this, right? How many straight lines I can draw? So if all the points were non-collinear, I could have drawn 11 C2 straight lines. Okay, I can draw 11 C2 straight lines, right? But what does this collinear, what will happen if these points are collinear, right? See, what will happen if these points are collinear? So 5, if there are 5 normal points, that means if there are 5 non-collinear points, okay. So if there are 5 non-collinear points, so 5 non-collinear points will give you 5 C2 straight lines, okay. 5 non-collinear points, 5 non-collinear points will give you 5 C2 straight lines. Agree? Right? But if there are 5 collinear points, that will give you only one straight line. There's a difference. Okay. If there are n collinear points, you can draw n C2 straight line. Sorry, if there are n non-collinear points, if there are n non-collinear points, you can draw n C2 straight lines. But if there are n collinear points, you can draw only one line, right? Because there are 5 lines, right? There are 5 points here. So 5 points, if you join these 5 points, it is always equal to only one line. It is always equal to one line. It doesn't matter which way you draw, right? You can also draw like this. You can draw from 1 to 2. You can draw from 2 to 4. You can draw from 3 to 5. You can draw from 5 to 1, right? Ultimately, it look like what? It look like a single line. It looks like a single line. That's it, right? So that's why 5 collinear lines are equal to only one straight line. Okay, not 5 C2. So that's why when I've written this 11 C2, okay. So when I've written this 11 C2, including these 5 collinear points, I have taken this for 5 points. I've taken this 5 C2 also, right? So 11 C2 means for this 5 points, 5 C2 is also included, right? But we have just discussed 5 collinear points is equal to one straight line, not 5 C2. So I'll subtract that case, right? I'll subtract minus 5 C2. So when we subtract minus 5 C2, this whole line is gone, right? Minus 5 C2. It's like this. But 5 collinear points is equal to at least one line. At least one line. So I should add one. So 11 C2 minus 5 C2 plus 1, right? What is the answer? You can solve it. Okay. 11 C2, 11 to 10 by 2. That is 55. Minus 5 C2, 10 plus 1. What is the answer? Answer is 46. So 46 is the answer for the case of straight lines. 46 is the answer for the case of straight lines. Okay. So this 11 C2, what is the concept here? Concept was this 11 C2 includes this 5 C2 as well. But 5 collinear points means in a single line. So 5 collinear points is equal to only one straight line, not 5 C2 lines. Subtract that 5 C2 and add 1. Okay, add 1. There is the funda. Okay. Now second we'll do for triangles. Okay. Now see how many triangles now can form easily, right? You can write it easily now. How many triangles now? So question 2 is for triangles. How many triangles? There are 11 points here. So again, had these 11 points been non-collinear, I could have formed 11 C3 triangles, right? But since these 5 points are collinear, this 11 C3 includes this 5 C3 also. So this 5C3, but 5 points in a straight line can never give you a triangle, right? So this 11C3 will includes this 5C3 also. But since this 5 points are collinear, it can never give you a triangle, right? So from 11C3, subtract 5C3. That is the collinear case. Subtract is 5C3, right? So what is the answer? You can just simply solve it. So what is 11C3? So 11 into 10 into 9 divided by 6. Okay. So it is like 66, I think. Sorry, 11C3. So 11 into 10 into 9 by 6. Okay. So 11 into 10 into 3 by 2. It is 165. So 165 minus 10 is 155 is the answer. Okay. So how many triangles I can form? 155 triangles I can form. So 11C3 triangles, and 11C3 includes this 5C3 as well. But this 5C3 doesn't give you any triangle because 5 points are collinear. Joining any collinear line, any 3 points in a straight line can never give you any triangle, right? This is the second one. Now let's move to third one. Third one is for quadrilateral now. Just solve it for quadrilateral. You can solve for quadrilateral, right? Suppose if there was 11 non-collinear points, how many quadrilaterals we would have got? So if there was 11 non-collinear points, we would have got how many quadrilaterals? 11C4, right? So there was 11 non-collinear points. We could have formed 11C4 quadrilaterals. 11C4 quadrilaterals if there was 11 non-collinear points. But in this case, this third question for quadrilaterals. In this case, 5 points are collinear. Again, same thing. See, but one extra punch is here, right? See, first is okay. From this 11 C4 quadrilaterals, I should subtract again this 5 collinear points. This 11 C4 includes this 5 C4 also. Right? But 5 points in a straight line will never give me a quadrilateral. So 11 C4 minus 5 C4, right? But in quadrilateral, one more case will occur, right? Understand this. See, what we are from total, I can form 11 C4 quadrilateral if there were all non-collinear points. But out of those 11 C4 quadrilaterals, we are subtracting those cases where joining any 4 points will not give you a quadrilateral. So one case is what? One case is when 5 points are collinear, right? But another case occurs here. That joining 4 points will not give you a quadrilateral, right? Let's have joined this 3 point and this 1 point. Now this is not a quadrilateral, right? I've joined again 4 points of this figure. 11, when you write 11C4, that means every possibility of group of 4 is taken, right? This also would be a group of 4 points. Okay, like suppose numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 points, right? So 2, 3, 4, 9 will also be a group of 4 out of 11C4. But if I join these 4 points, I will not get a quadrilateral, right? So I have to, in quadrilateral, I have to subtract one more case, right? Very important point. Subtract this one more case. So 5C4 plus what? One more case I have to subtract from total. So 5C4 plus what? This case is what? This case is out of these 5 points, selecting any 3 points. If 3 points are selected out of this 5 points, that is 5C3. So if 3 points are selected out of this 5 points, 5C3, and means multiply, and out of the rest 6 points, out of these 5 points, any 3 points selected, 5C3, and out of the rest 6 points, any 1 point is selected, that is 6C1. So 3 plus 1 is 4 points, right? So 4 points out of 11 points. So out of these 5 points, any 3 point being selected, and out of this rest 6 points, any 1 point being selected, that will give you a triangle. So this case also we need to subtract in case of quadrilateral. Okay, so very important point. This is the answer. You solve it, is the answer, right? So if I join 3, 4, 5, so 3, 4, 5 will 6 will also give me a triangle. It won't give me a quadrilateral, right? So out of this 5 points, selecting any 3 points, and rest 6 points, selecting any 1 point. So this is the answer, right? So I've given similar question in the quizzes. Okay, please solve the quizzes, and see the video solution also there. Okay, thank you. Next we'll see in next video. Please revise it. Very important concept we're discussing. Please revise it. Thank you.